So on the first question, I had the kids add up the odd numbers between 1 and 100, but then 100 isn't odd, of course. So it started off with 1, and then 3, and then 5, and then dot, 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 and then it went to 99. And we talked about it and figured out there is 50 numbers, because for each number we start with, the one after that goes away. So then, clearly, if there were 100 numbers, and for every other number is getting knocked out, there's 50. So I've got this formula. So, Mr. B, can you tell me S sub n is equal to, tell me what, let's use this one.
Okay.
Tell me what to put in.
N is 50.
Okay, so 50 over 2 times?
Times 2 times 1.
2 times the first number.
Yep. And then in or the plus.
Okay.
In parentheses, you have your n minus 1, so it's 50 minus 1.
50 minus 1 times?
Times 2.
2. 2 is the common difference. All right. So that's 49 times 2 plus 2. So what's 49 times 2? 80, 98, I think?
Yeah.
Plus 2 is 100?
Yep.
And then I do 50 divided by 2 is 25 times 100 is 2,500. Raise your hand if you had 2,500. Okay, good. All right, so that's a good starter problem. Here's another one that stumps a lot of people. Do that same exact thing, except do the problem this way. Make me one of these. It's called a sigma. Put that problem in sigma notation. I'm gonna pause for a second and give that one a try. So let's see how you did on making a sigma for this. You always start with a 1 there, and then, this is important, I'm not gonna put a 99 here, because that's not how many terms I have. How many terms do I have? So I need a 50 there. Okay? And then you put the term finder, which is one of our formulas for arithmetic. It is a sub n equals a plus n minus 1 times d. And I put this part right here, a plus n minus 1 times d. And yes, you can absolutely multiply it out. Our first term was 1. Our number of terms was 50. And our d is 2. And dang, I hope you get to the end and you do something like that and you go, wait a minute, I'm supposed to have a variable. Which one of these is supposed to be left as the variable? The n. So I'm going to erase this 50 and put it back to an n. And you can multiply this out if you wish. If you wish, you would go like this, and then you'd have 1 plus 2n, and then 2 times the negative 1 is minus 2, which would simplify to 2n minus 1. This would totally work. And how many of you had either one of the two that I just circled in blue? Okay, good. So what else do you have to know? Well, a lot of things. How about if it's a bunch of things that are multiplying, but you have only like scant information? It's multiplying, so this is geometric. Okay. The second term is 40. Is there any way to know what the answer is yet? No, I have to tell you something more. Now, if I told you the first term, would you be able to tell me pretty much everything? Yeah, so telling you the first term is like a little too easy. Okay, let's tell you the fourth term. It's 1,000. Now, I know you could guess and check your way to this one, but don't, because I'm telling you, the one we do on the test, you'll never be able to guess and check. You instead need to write an equation for this and an equation for that. You don't know D and you don't know R, so you leave them in as equations, okay? So make an equation for both of those. I'll pause for a second. Now you write me 2 equations. Remember, our geometric equation for the term finder is a sub n equals a times r to the n minus 1. Make me 2 equations and then solve the system of equations. Okay, let's break the ice here, and I know there's a few people that are just lost. So, Hunter, help them out. How do you put in the 40, and what do you put other places?
You put a 40 in for A.
All right. So 40 is our first term. Is that what you're saying?
Yeah.
It's not though. Thank you for trying. It's not, we don't start there. What do you think?
Well, there's also a different way you can solve it.
There is a different way, but I want to start with this way because I know this way is going to work for the future. So, all right, you guys, this is not that hard. That 40 is a sub n. That is a term. And do I know a? No. Do I know r? No. And then is n minus 1. Do I know n?
No.
Yes, I do. This is the second term. So I know n is 2. There is an equation. I could simplify it because I know 2 minus 1, and that's 1, right? So 40 equals a times r. This is a way to do this. And I know there's another way, and I'm not even going to explore that way because I feel like it's not teaching you how to write equations and solve them. And that's a crucial skill. Trying to write equations from these is a crucial skill. You'll need it on the test. And I know you also need it for the ACT. So learning how to write these equations is really valuable. All right, so now we're going to do it again, except with 1,000. I'm going to write that above it just to make it really clear where I'm putting them. 1,000 is my any term, equals a times r to the, but that's my fourth term, so 4 minus 1. I'm going to rewrite that, and I get 1,000 equals a times r to the third. Now if I take these two, I can put one in the other and I can solve. I'd like you to do that next. If you did it another way, good for you, but take a moment and make sure you know how to solve a system of equations. It's a basic algebra skill. It's super critical that you know how to solve a system of 2 equations. Heck, when later this year, we're going to have systems of 3 equations, where you're going to have 3 variables and 3 equations. So you got to know how to do it when there's just 2. And again, I do substitution. You can use elimination, but it's tricky in a problem like this. Okay, just to get us started here, Mr. Cummings, can you tell me how to do substitution to solve this thing?
Don't you get A on its own?
Yes, let's get A on its own. What is A? We'll do it right underneath this problem right here. What's A?
That's negative A is equal to.
Nope. Don't need negative A. We're just going to divide both sides by R. So 40 over R. There we go. Now everybody put that into the other equation. There's A. Put it right there. Okay. 1,000 equals 40 over R times R to the third. This is so good for you. There's so much canceling and stuff you need to understand. Like right here, this is going to cancel with one of these R to the third, so it's going to become R squared. You get that? Then I'm going to divide both sides by 40, and I have 1,000 over 40 equals R squared. And then I'm going to simplify it because that'll be 500 over 20. And that'll be, cancel those, 50 over 2, which is 25, equals R squared. Cool. So R equals 5. Done. Wrong. Really important. You can't just like jump. We're in a hard class. You square root, you get absolute value of R. If you haven't learned that yet, I feel really bad for the people that the teacher just gave a shortcut and said, so R equals 5, and just slapped a plus and minus on somewhere. You need to know that this is the absolute value of R, which then leads to 2 answers, R equals 5 and R equals negative 5. There are 2 answers. It would work just as well to multiply by negative 5 twice. See what I mean? Okay, so there's 2 answers, and that's very likely something we would test you on, because I've told my kids from first semester, we're going to do this about 5 times, where you got to solve this, and you got to remember there's absolute values, so then there's 2 answers. Okay. Good. Glad we talked about that one. And the last one I want to talk about, no, wait, second to last. I want to have one where it goes back and forth. Like, let's say it starts at 6. And if I'll just tell you what I'm doing. I'm multiplying by -2, and I get -12. And I'm multiplying by -2, and I'm getting +24. Do you see what's happening here? If I did the sum to infinity, are my numbers converging and therefore I can do it, or are my numbers diverging? These numbers that I'm adding here, that I keep adding, like the next one would be -48. Are they converging on something? Like getting closer and closer to something? No, they're diverging. They're going towards positive and negative infinity. So that's diverging. You cannot add the sum to infinity. Okay. So what could you do with this? Could I add up like the first 10 terms? Yes, you could. Everybody do that. There's a formula for that. Pause while you try that one. Okay, so I would have used, for the geometric, I would have done S sub n is equal to A times 1 minus r to the n over 1 minus r. And now I'm going to put in everything I know. I know A is 6. And then 1 minus r is -2. To the n is the 10th term, so 10. And then this is just -2. Then I would go 6 times, I would definitely use the calculator for 1 minus -2 to the 10th. And I would have been careful with my parentheses too. And then on the bottom, I'd have 1 plus 2, which would be 3. Wait. And actually, 6 over 3 cancels, right? I can write this as 3 times 2, and this is 3 times 1, and the 3's cancel. So that's just 2 times this. So 2 times 1 minus -2 to the 10th. See what happened there? I just replaced my 6 over 3 with a 2. All right. So then I'm using my calculator here, and I do parentheses 1 minus parentheses -2. The negative key is different than the the minus key is different than the negative key, and that's a negative, and that's a minus. It matters weirdly. To the 10th, and I times it by 2. And I have -2046. Can anybody verify that? A lot of people are saying yes. Now, if you didn't get this, I would retype that on your calculator, because I think you need to know that you're doing it wrong. That's how that works. This is a negative key. No, wait, that's a minus key, and this is a negative key, and maybe that's what messed you up. You need the parentheses. Okay, the -2046 is what I got. All right, and then I wanted to do one sum to infinity that actually would work. So I'm going to let a kid pick it. Sammy, if you pick a 5 to start with, what could you do to it so that you could do an infinite sum? Could you add something to it? No, that wouldn't make an infinite sum. Oh, wait, we get 2 Sams. Just be careful. This is Sammy,
Yeah.
unless you go also by Sammy.
No.
All right, so Sammy's in the front here. So go ahead, Sammy. What could we multiply by that would make this thing actually get a sum to infinity?
You could do like 3.
Okay, if I times by 3, I get 15. I times by 3, I get 45. I want you to think about that. Are these numbers converging on something? No, that's going to infinity. There we go. All right, let's do a half. So if we use r as 1/2, we times this by 0.5. Half of 5 is 2.5. I actually think it's smarter to use fractions. I know a lot of people think decimals are easier, but then you're timesing by 1/2, and then you just have to times the denominator by 2. So now it's going to be 5/4, etc. So how many should we add up? Well, we can do infinity. Let's do the sum to infinity. There's a formula for that. Because people at home might not be like having that set of formulas right in front of them, I'm going to give it to you. It's on the board here. It's A over 1 minus R. Henry, tell me how to do it.
You put 5 into A and 1 half into 5.
And 1 minus 1 half will give us a half. And what do you do with that? Divided by a half.
You flip the denominators and multiply.
Times it by 2 over 1. Answer is 10. That's series. This one right here would add up to 10. Is it always just double the first number? No. It isn't always just double the first number. It depends on what the R is. Okay. If the R is a half, can we answer that question? If the R is a half, is it always just double the first number? Yeah, because if R is a half, then we'd have 1 minus a half, which is divided by a half, which is times by 2. It'll always just be the first number times 2. If it's R is a half. But it's honors pre-calc. Are we likely to use a nice, clean, simple little thing to multiply by? No. So it's pretty not likely that it's going to be timesing by a half. Okay. All right, that's sum to infinity. And the last thing is binomial expansion. Let's talk about that. Negative 2x minus 1 over y. And that's a really brutal one. You know what? Wait, we'll do that maybe later. I'm just going to start with an easy one. 2x minus y. Let's do it to the third. And do that one all the way out so you can know all 4 terms. Mr. Brahma, how do you start this thing?
I'm gonna start it. Put 2x.
Yep.
And all the little.
Yep, but let's start with 2 to the power of...
Oh, that's 2 to the power of 3.
Okay, good. And then 2x to the...
2 the second, and then the first, and then the second.
Good start. Ashana, what's next? Yep. And last but not least, there's a little something in front of each one. Drew, can you help us with what's in front of the very first one here? 3 choose 0. Could you use a calculator for that? Absolutely. And if you don't know where this is, it's where NCR is. So you can look it up under the catalog button, which is right above the 0, and then alphabetically find the N's, because this is NCR. Option B, I'm giving you a shortcut. You could do this by using math button and then arrow over to probability, and you'll see it. That's probably the quickest way to get there. You might be like, oh, I can do this in my head. Okay, cool. But you won't be able to on the one we have on the test. So you better know how to do NCR. So just check it with that 3 choose 0. If you do it right, your answer comes out to 1. You know what I mean? We're just, even though it's an obvious one, you have 3 things and you choose 0 of them. There's only one way. And you know that the Pascal's triangle thing has a 1 down the outside, so it has to start with a 1. But you should make sure that you know how to put this in a calc. Because the one on the test might be like 7C4. And you're never doing that one in your head unless you've memorized this. 3 factorial over 3 minus 0 factorial, which would be 3 factorial, with an extra one of these, 0 factorial. And that way you could do it in your head. And that one is 1. Yay. If you got it this way or you got it from your calculator, either one's okay. Calcs are allowed in this test. All right. So we need one of those little choose things for each of these. 3 choose 1, 3 choose 2, 3 choose 3. just to save time, I would like you all to compare the third term. Everybody get this one. With the kid next to you. Zoom in on just the third term. Take a second, get your final answer. I'll pause while you get that together. Okay, so let's see how the third term went here. This one, when you type it in your calculator or you do it in your head, there are 3 different ways to do that. This 2 to the 1 is just 2. 2 times 3 makes 6. X to the 1, just x. And negative y squared. Is that negative going to stay in my answer? No, because it gets squared, so then it's just y. Raise your hand if you had 6xy. Okay. Any questions about that? Or did I screw something up, which I might have? Yes?
Wouldn't it be at 6xy squared because the y is...
Thank you. There's a squared there, big as life. I just forgot to say it. Sorry, you are correct. 6xy squared. And those of you that raised your hand, I'm sorry, I wasn't trying to sucker you in. I just forgot to say the squared. All right. Any other questions about binomial expansions? Like, I think you get the same process would apply if we had this. If we had this, and I said, which term has an x to the 4th in it? Do you get on this one, it wouldn't be too hard to tell which term would have an x to the 4th in it? I have 8 blanks, but which term has x to the 4th in it? Well, then I'd start with negative 2x to the 7th, and I'd just keep going until I get to the 4th, right? This would have to the 6th, to the 5th, to the 4th. Oh, so you're talking about this one. And then you'd have to figure out that term. Do you get, we don't have to do all of them. We just have to do that one then. All right, what's the other way to ask that question? It would be like, which term is independent of x? As in, is there a term that doesn't have any x's in it? In this case, there wouldn't be. There wouldn't be any term that was... No, wait, I'm wrong. The last term wouldn't have any x's in it, would it? Because it'd be negative 2x to the 0. If you're independent of x, that means you don't have an x in it. So the last term would be the one that was independent of x. Okay, as opposed to if I said, like, what's the term that has x to the 4th in it? Because that, again, was this one. Because this would be to the 7th, to the 6th, to the 5th. That's negative 2x to the 4th. It's just a fancy way of telling you to find that term. Okay, now you have the rest of the time to find the worksheet that looks like this and do it. I will cut it down for you just a smidge. I'm going to say you may skip that one. I think this is actually too easy, so let's skip that one too. And on this page, man, I can't even skip any of those because they're all too valuable. Like, we have stuff like that in the test. On this page, man, we definitely have something like this, but this is actually too easy. No, wait, I'm wrong. This one we'll cross off. Cross off 7, do 8. And I'm going to leave 9 as optional. Like, it would be good practice, but I'm trying to keep this assignment doable. Okay, so those are the ones that I would skip if I were you. Okay, and that's all I got for the video for the review for the big test. Hopefully you study up, and tomorrow have a great performance.